What causes overheating in high-power chopper circuits? Imagine a circuit that switches power on and off rapidly to control energy flow. If it gets too hot, it can cause serious problems. Let's find out what makes these circuits overheat. One big reason is electrical overload. When the circuit handles more current or voltage than it was designed for, the power semiconductor devices like metal oxide semiconductor field effect transistors or insulated gate bipolar transistors conduct too much current. This causes them to heat up because of conduction losses, which happen when current flows through resistive parts of the device. Overloading can happen if the load demands more power than the system can handle, or if the components are not correctly rated for the application. Switching losses are another major factor. High-frequency switching, which is common in chopper circuits, causes energy to be lost each time the device turns on or off. When the switching frequency is very high or the transitions are slow, these losses increase. This extra energy turns into heat, raising the temperature of the semiconductor devices. Inadequate heat dissipation also plays a big role. If the system does not have enough heat sinks, fans, or cooling methods, the heat generated cannot escape efficiently. This leads to a buildup of heat in the components, which can cause damage over time. High resistance in the power devices is another cause. Devices like metal oxide semiconductor field effect transistors have an on-state resistance, which causes power loss proportional to the square of the current. When currents are high, these losses grow, producing more heat. Harmonics and ripple currents created by switching can also increase losses in other parts like inductors, capacitors, and wiring. These additional losses generate more heat and can lead to overheating if not managed properly. Fault conditions such as short circuits, overvoltage, or incorrect control signals can cause abnormal current flow. These situations lead to sudden and intense heating, which can quickly damage the circuit. Component quality and aging matter too. Over time, semiconductor devices and passive parts degrade. This increases their resistance or reduces their ability to conduct heat, resulting in more heat being generated. Loose or faulty connections are often overlooked but can cause localized heating. Poor solder joints or loose terminals increase resistance at contact points, creating hotspots that can damage the circuit. To prevent overheating, engineers carefully select components with appropriate current and voltage ratings. They optimize switching frequencies and gate drive signals to reduce switching losses. Proper thermal management, like heat sinks, fans, and thermal interface materials, is essential. Ensuring solid electrical connections and designing control algorithms to avoid overloads also help keep temperatures in check. In power systems and renewable energy applications, like DC-DC converters or motor drives, overheating can lower efficiency and reliability. That is why temperature sensors and protection circuits are used. These systems monitor temperature and can adjust duty cycles or activate resistors to safely dissipate excess energy, protecting the circuit from damage.